Sustainability friends, warmly welcome to this global final of the Iaq Ea Quality Sustainability Award 2025. I'm very glad to have you with us. I think this final is also a good opportunity to learn more about how we really could work with sustainability. Everyone is talking about it, but we need to have a more active work, and that's why Iaq Ea since 2020 has been given this award. I will make a short introduction here, telling a little more about Iaq Ea and also about our view on the link between quality and sustainable development. Starting with Iaq Ea, we are an independent, self-supported, non-profit, non-governmental organizations founded in 1966 by the three main gurus at that time in quality: Val Feigenbaum, Kauri, sustainability and future generation as probably the most important things for us to focus on. Iaq Ea as an organization, we do quite a lot of things. We are a small organization, but we are connected through our members to most big quality organizations all over the planet. We are the international, the global organization that also try to build bridges between all those. We have three kinds of members. We have executives, we have practitioners, and we have researchers. We do quite a lot of our active work through think tanks activities within different important areas of quality that we try to develop new knowledge. We run projects, we are connected to research. We have the Iaq Ea Doctoral Academy that we also try to focusing on fostering the next generation of quality professionals. We are active in research, we publish, we try to be seen at social media to spread our knowledge and also promote quality. We, as I said, cooperate with many other organizations. We give a number of different awards. This is one of them. And then we organize different kind of meetings, conferences, and symposiums. Over to the link between quality and sustainability. This is something that we strongly believe in and try to get more people to understand, and that way get a more active and fact-based related to sustainability. As most of us know, there is a lot to do. When we year after year follow the reports from different organizations that are focusing on the condition of our planet and what will happen to future generations, we see that some things are positively developed, while a lot of things need much more focus. Here is one of the latest reports from the United Nations that if you look at it, you see it's a lot of red and yellow and very few green areas. So we need to focus much more. And we believe that one of the reasons why things goes that slow is that this is very complicated. And I think people often not understand enough of how much fact-based systematic work that it needed to proceed. There is easy to get up with simple solutions, but mostly they are not working. Especially if we look at all those dimensions, 17 UN sustainability goals and all the targets and indicators behind. We also understand that the risk for goal conflicts are huge. For instance, it's easy to say that we can start consuming, but that will of course immediately result in huge financial and social problems. So we need to have a more holistic and fact-based approach to sustainability. To explain our way of looking at it, we used to use two perspectives on sustainability. The first one we call a macro perspective on sustainability. And that's probably that where we have best knowledge today. And this is about how Earth and future generations are affected by environmental, social, and economic effects. This knowledge is very, very important, of course, to be able to understand what we should give priority and to, and what company really should struggle with. But even if it's necessary, it's not enough. Because what we see on this picture is more or less symptom on what's happening in this factory. It could be a city, it could be your home, or whatever. And something that is very obvious to us quality professional is that we should never try to solve symptoms. We need to understand the root causes behind this. And that means that we need something more. And that is what we described with this micro perspective on sustainability, because the root causes to all those effects that comes due to human activity is happening in the processes in our organizations, in our factories, in our cities, or wherever. And here it's very important to try to understand more how we create value for both current and future generations in an effective and efficient way. And we also know from a quality perspective that the waste is extremely high. Rather small percentages of the total resources used will lead to a real value that are important for people, customers, humanity. It's also very interesting that the quality profession has, since more than 100 years, developed a lot of knowledge, philosophies, methods, and tools that are very helpful and could help us to improve our organization, focusing on doing the right things the right way, and that way getting more value out with less use of resources. This has been applied mostly for the success of organization, to be able to fulfill their actual goals and visions and meet the needs of the customers to deliver quality here and now. But if we think of this on a larger perspective, future generations are also future customers, and the same philosophies, methods, and tools can help us to create value for them too, and get rid of all these waste that exists. So that way, quality is a driver of sustainable development. This is something that we have understood from quite a long time in the quality profession, but it has been rather difficult to get other people outside our community to understand this fully. And that was the reason why we started up this work 2019, and the first time gave the award 2020, because we wanted to create success stories. We wanted to clarify the link between quality and sustainability. Until today, we have had more than 300 projects applying for this award, and that had created a lot of success stories. But not just success stories, also a lot of data. So our researcher at Iaq Ea have now started to do research and publish paper after paper after paper that in different way analyze and prove that quality is this very important driver of sustainable development. And this also means that to achieve a more sustainable development, we need a combination of what we can call sustainability competence, what we see from all these different organizations that are focusing on the 17 areas behind the 17 UN sustainability goals. But this we have to combine with what we can call quality competence, the knowledge we have, to be able to make breakthrough in the different root causes behind those. If you are interested to learn more about Iaq Ea and our work, please visit our webpage, iaquality.org. Now over to today's program. We will listen to 11 very interesting projects from different countries all over the world. These are the ones that have been selected based on a huge number of projects that have applied. So now we are in the final. We will listen to them one by one. After that, we will have a break with a guest speaker, Carol Strandberg from Canada, that will share her experience on how to work with sustainability. And in the end, we will have the prize-giving ceremony. So now we'll introduce the first project. That is coming from China and is the CTE Corporation. And the presentation is about intelligent stop, green future, breakthrough and application in energy saving reliability assurance technologies for 5G base stations. So please.
Hello everyone, I'm Jiafang Zhao from ZTE Cooperation. It's my great honor to be here to share our project. The topic is Intelligent Start-Stop Grid Future, Breakthroughs and Applications in Energy-Saving Reliability Assurance Technologies for 5G Base Stations. ZTE, founded in 1985, is a global leader in ICT solutions. We provide network services for more than 160 countries around the world. However, with the large-scale deployment of 5G base stations, the demand for energy saving has become increasingly prominent. I will introduce this project from the following 4 chapters. First, the project background. Under the green strategy of China as a key area of energy consumption aims to improve the energy efficiency of 5G base stations by more than 20% by 2025. Traditional base stations are like hardworking workers who work 24 hours a day. Is it possible to allow these workers to take a break during their rest time? The answer is yes. ZTE has developed an intelligent start-stop strategy that allows these stations to enter a deep sleep mode during low traffic periods. However, a new challenge has emerged. When the base station transitions from continuous to intermittent, its working profile undergoes significant changes, which poses a new challenge to the reliability. Without solving the reliability problem, intelligent start-stop strategy cannot be commercially used. Our project focuses on the research of ensuring high reliability operation of equipment under the strategy. Next, set project goals. The overall project is deployment intelligent start-stop strategy without reducing equipment reliability. Chapter 2, Project Solution. First, we establish a reliability assurance process supported by the 3 major quality tools: FMEA to identify risks, DOE to verify risks, data analysis is to assess risks. Then we establish the technical roadmap based on the quality support tool platform, which include 6 key steps. Chapter 3, Project Practice. Our team is composed of members from the Quality and Reliability Department, Hardware R&D Center, Software R&D Center, and Component Engineering Department. The first step is to analyze the working profile. We build a 24-hour working profile model for 5G base stations, including 5 phases: normal operation, rapid power off storage, low temperature start, power on operation. Based on the work profile, we identify the risks through FMEA 7-step method. Take 2 typical AAU devices as an example. We use FMEA to identify 300 items of potential failure modes. In addition, we output an intelligent start-stop pre-identification risk items, which includes 6 major types of risks. Next, we conduct testing design and risk verification for the 6 major types of risks. First, solder joint failure risk verification. The device solder joints undergoes temperature cycles every day due to the frequent power on and off. The key to DOE is to determine the field dirty. The dirty is determined by both external and internal causes. According to the analysis of global meteorological data in the past 8 years, the field dirty is determined. By testing on 11 typical models, the solder point life can meet requirements, the risks can be released. The second item, condensation risk verification. We formulate the condensation test scheme, temperature and humidity test stress. By testing on more than 20 models, there is no condensation is found. The risks can be released. The third item, low temperature and electronic stress risk verification. By testing on 11 typical models combined with small-scale field trials, the risks can be released. The fourth item, single timing anomaly risk verification. By testing on typical models, the single timing risk is countable. The fifth item, lightning strike risk verification. By testing on 12 typical models, the lightning test is passed. The sixth item, frequent power on and off risk verification. By testing on 17 typical power supply models, the indicators meet the requirements and the risks are countable. To verify long-term reliability, we collect, analyze, and verify the field data, collect a total quality of no less than 200 devices for 6 months, including Northwest China, Northeast China, Southwest China, and Central China. Reliability-related risks have been improved and well controlled. Chapter 4, Project Results. All the objectives are achieved. The intelligent start-stop strategy has been put into commercial use, including slipping power from 200 watts to 5 watts. In addition, this project has made remarkable achievements in connection to UN Sustainability Development Goal 13 climate action. The strategy has been deployed on over 500,000 devices, reduced electricity consumption by 249 million kilowatt-hours annually, saving $20 million annual costs. The annual reduction of CO2 emissions is about 134,000 tons. And the reliability assurance solution can be directly applied to 5G, 5Ga, and other devices with energy-saving requirements. In addition to the communications industry, the reliability process and methods can be widely used in railway, automobile, and electronics. In order to maintain the capability and copy it to other products, we have standardized the methods and process, established 15 cooperate standards and design specifications. Currently, the intelligent start-stop strategy has been deployed in 22 provinces across the country. It has operated for 14 months without any reliability issues. It has reduced energy consumption by 23%, achieving the GREE strategy target of a 20% reduction for 5G base stations. ZTE just released its annual sustainability report in June 2025, demonstrating our practice achievements in the ESG field. This is the 17th year that we have proactively disclosed our achievements in fulfilling our responsibilities to the society. We always regard sustainable development as the core of our strategy. This is the end of my presentation. Thanks for your listening.
Okay, may I ask the jury members to put the mic on and video on, and I see Mrs. Zhao is already available to answer questions. Thank you for the video. Anyone with a question to start off? No.
Let me ask one question.
Okay.
Go ahead, Radhika.
Thank you for your presentation. You showed several FMEAs and you showed risk. So what was the major failure mode that you found out, and which failure mode actually got corrected Because that was not so visible in your presentation. In the
Okay,
6
thank you.
systems.
Okay, thanks for your question. We use FMEA to identify the potential risks. Taking two AAU typical devices as an example, we find about 300 items of the potential risks. The major types of these risks can be concluded to 6 major types of risks, as we have just shown in the video, including solder joint failure risks and the condensation risks and the low temperature start risks and the strike risks, and we use for the high risks identified by FMEA, we analyze the sensitive stress that causes the failure and use the DOE to design the test to verify the risks one by one. I hope that can address your question. Thank you.
No, not really. So that I understood. I wanted to know, within these, is failure mode same as risk in your understanding? Is failure mode the same as risk, or they're different?
They are different, not all the same. Different type model of the product has different precedent. Yeah, because the using area, the applied area is different. The environment, the sensitive stress is different. So the failure is not exactly the same.
Okay.
Okay, thanks for your question.
Thank you.
I can go next.
Yeah, sure.
Okay. Thank you for your presentation. So my question is about clarification. You mentioned the saving, the reduction of the emission was 134,000 tons of CO2. What percentage of the total does it include? The overall emission?
Okay, what percentage of the total does it include? It's the reduction of the energy saving is about 23% of all the overall emission. Yeah.
23%. So you already passed the target that you set. It went beyond the target that you set for the CO2.
Yeah, the target is to have the reduction of emissions about 20% from the China Green Strategy requirements. Our project output the 23%.
And is it being verified by a third party, the statistics, and validated by a third party?
Yes, we have verified it, and sorry, I need to understand the question deeply.
Yeah, sure. So is the emission reduction and the numbers that you mentioned are being validated by a third party organization, or it was just an internal reporting?
Yeah, it has been verified by the third department. We calculate the data from the products deployed across the typical regions in China, and they are verified by the third department or organization.
I don't hear anything anymore. Can the studio do something?
I hear too.
Yes, I can hear.
Nice.
Okay. Yeah, thank you. Thanks for your answer.
Yeah, thanks you.
I see Jose Carlos has his hand raised, but could somebody sign whether you still hear me or not?
Yeah.
Yeah.
Okay, but I don't hear anything anymore.
Yes. I can hear you.
Jose Carlos, last question, short, please.
May I go next? Yes, sure. Congratulations on your project. Excuse me. You talked about new standards. You established 15 corporate standards. Are those aimed at being best practices for your company and to be work within your company, or are you aimed also to share it across the industry and maybe other companies?
Okay, thanks for your question. First, the reliability assurance solutions established in this project can be used to 5G, 5Ga, and other devices with energy saving requirement. And currently, it's already has been extended from AAU devices to RRU and BBU devices. And this is for our company. But in addition to the communications industry, the reliability process and methods, as we have shown, including working profile analysis, FMEA risk identification, sensitive stress analysis, DOE test design, field data collection, and we have established in this project can be widely used in the fields such as railway, automobile, and electronics for the potential risks. We have participated in the China CSTD competition and the Reliability Technologies International Conference. Our project methods has been shared with other companies, and we also received good feedback from them. Okay, I hope that addressed your question. Thank you.
Yes, thank you.
Sorry for the interruption, but in sake of time, we need to go to the next project. Thank you very much. And
Okay,
I'll see if I can solve
Thank you for all.
my sound problems. Thank you.
Thank you.
The Guojiao Wanzhoushan Offshore Power Transmission Project is not only a major energy infrastructure project, but a model practice that drives technological innovation, ecological friendliness, and social progress through advanced quality management concepts. Addressing era-defining pain points, resolving its sustainable energy dilemmas with the major projects. As China's largest island city, Zhoushan City administers 2085 islands, with 1.176 million residents and 771,500 enterprises. For a long time, its power supply faced three critical dilemmas: reliance on diesel power generation, which was costly and carbon-intensive; sensitive marine ecology, where conventional power transmission projects were prone to damaging fishing grounds and biological habitats; poor reliability of traditional power transmission technologies, high construction and operation costs, and significant power loss during long-distance transmission. These limitations render them inadequate for supporting deep-sea development and hinder the upgrading of pillar industries such as petrochemicals and marine engineering. To solve these problems, State Grid Zhejiang Electric Power Company Limited identified innovation as the driving force, aligning with the United Nations Sustainable Development Goals, and led the construction of the Guojiao 1 project. With a total investment of 9.12 billion yuan and a construction period of 5 years, the project has a design service life of 40 years, 60% higher than the industry standard. It built the world's first 500 kV cross-linked polyethylene insulated submarine cable transmission line and put into operation the world's most complex 220 kV 5-terminal voltage source converter high voltage direct current transmission system, completely resolving Zhoushan City's predicament of isolation from the mainland power grid. Involving 87 inhabited islands, completely resolving Zhoushan City's predicament of isolation from the mainland power grid and laying a foundation for sustainable development in these islands. Aligning with global goals, quantifiable achievements in 3 sustainable dimensions, Guojiao 1 accurately aligns with Sustainable Development Goal 7, Sustainable Development Goal 9 and Sustainable Development Goal 11, which are respectively affordable and clean energy, industry, innovation and infrastructure, as well as sustainable cities and communities, delivering results that are data verifiable and impact perceivable. For Sustainable Development Goal 7, building a new system for island clean energy supply, Cross-sea grid interconnection allows Zhoushan City to eliminate its reliance on local fuel-fired power generation, while its 5-terminal voltage source converter high-voltage direct current system ensures the complete integration of all clean energy generated on the islands. Further, it has reserved access channels for deep-sea and distant offshore wind farms, which can support the grid connection of 1 million kilowatt of new energy, such as wind and photovoltaic power, in the future. This provides a long-term solution for the transformation of the island's energy structure, truly realizing clean electricity for all. For sustainable development, Goal 9, leading the innovation and upgrading of the offshore power transmission industry. The project has set 19 world records and independently developed 24 core technologies, filling multiple gaps in the industrial chain. For example, the world's first cross-sea transmission towers were erected by helicopter and steel pilot ropes were laid across the sea by helicopter. Two 380-meter towers, the tallest cross-sea transmission towers in the world, were completed. The world's longest single jointless 500 kV cross-linked polyethylene submarine cable was independently developed and successfully laid. What is being shown on the screen now are the scenes of helicopter-assembled transmission towers and the construction of the 500 kV cross-linked polyethylene submarine cable. Key application of 500 kV 3-core extra high-voltage long-distance cross-linked polyethylene submarine cables has reduced power loss by 12%, increased laying efficiency by 50%, decreased route space by 30%, and eliminated the risk of marine oil pollution. The 10,000-ton class cable laying vessel, Qifan 19 seconds, and its supporting equipment mark China's independent capability to implement complex deep-sea power transmission projects, with the technology already applied in the supporting transmission line of the Hainan CC1 offshore wind power project. What is displayed on the screen now is a detailed introduction of the submarine cable laying vessel Qifan 19. More importantly, the technical standards and management specifications formed by the project can be replicated in scenarios such as cross-sea projects and island interconnection, offering valuable insights for the global development of the submarine power transmission industry. For sustainable development, Goal 11, empowering sustainable development of cities and communities. The project has added 3 million kVA of 500 kV transformer capacity. The voltage source converter high-voltage direct current project involves the construction of 5 converter stations in Dinghai, Daishan, Qushan, Sijiao, and Yangshan with a total capacity of 1,000 MW. Following its completion, the project has provided Zhoushan City with a stable and reliable power supply, significantly supporting its socio-economic development. Zhoushan achieved significant growth in regional economic output and per capita income. Taking the year 2024 alone as an example, Zhoushan City's gross domestic product increased by 5.9% year-on-year. Industrial investment rose by 18.5%, and 75 key projects in 5 major industries were launched. Residents' living standards continue to improve. The per capita disposable income of all residents increased by 4.5% year-on-year, with rural residents' income growing by 5.7%. This progress has been supported by a stable and affordable electricity supply, which has provided reliable power security for Zhoushan's economic and social development. The popularization of clean electricity, such as household appliances and electric vehicles, has ameliorated the city's air quality and living environment, enhancing residents' sense of happiness and gain. Focusing on the core of quality, an innovative paradigm for whole life cycle quality management. Throughout the development and implementation of the project, it adhered to the Quality 5.0 philosophy and a process-oriented approach, systematically applying multiple quality management tools and methodologies. Moving beyond the scope of traditional engineering quality, the project established a holistic quality management system based on a broadened quality perspective. This system encompasses the entire life cycle, covering planning and design, construction and operation and maintenance, ensuring comprehensive quality assurance across all phases. Planning and design phase. To address global challenges and overcome constraints, the team has conducted independent innovation in power transmission technologies and materials, construction techniques and equipment, as well as management. technologies and models through dedicated research and specialized design. The team innovatively proposed the whole life cycle multi-objective comprehensive optimization planning and design method, integrating tools such as quality function, deployment and life cycle assessment to scientifically balance technical performance, economic costs, safety risks, environmental protection, and social impacts, ensuring the optimal solution. Construction and implementation phase, a visual monitoring and information-based command and dispatch system was deployed, and the value stream mapping method was applied to accurately identify and eliminate waste in material flow, information flow, and operation processes, significantly boosting construction efficiency and resource utilization. For example, it applied the submarine cable three-dimensional online monitoring system, the submarine cable synchronous data acquisition and transmission system, the submarine cable turntable digital model, the catenary laying model, the submarine cable intelligent catenary laying system, and the submarine cable smart management platform. Operation and maintenance phase, an innovative integrated land sea air intelligent monitoring system was built, converging drone inspections, underwater robot detection, and satellite remote sensing technology to achieve round-the-clock comprehensive monitoring of transmission lines. Additionally, collaborative operation and maintenance and the differential maintenance model based on equipment health status were implemented, greatly raising operation efficiency and system reliability. Guojiao One takes quality as a link to closely connect technological breakthroughs, ecological protection, and social value, while offering a Chinese solution for the sustainable development of global island energy. It sets a practical benchmark for how large-scale infrastructure can drive sustainable development through quality. The project has been awarded the Tianyao Jim Civil Engineering Prize and the National Quality Engineering Gold Award, which represent the highest honors in the field of technological innovation and scientific research in China's civil engineering industry. Thank you all.
Thank you. I was able to solve my sound problem. Can you all hear me still? Yes. Okay, good. Any questions? Samaya?
Yep.
Go ahead.
Thank you. Thanks for your presentation. So my question is about the trade-offs between energy goals and the marine ecosystem health. So could you elaborate on what environmental risk assessment did you conduct to evaluate that all these gains of SDG goal for energy and sustainable cities did not come at the cost of just impacting negatively the health of the ecosystem below the water? I mean, SDG 14, which is about the health, the life below water. So can you elaborate what risk assessments did you conduct to make sure that it's not going to negatively impact that?
Thank you for your question. Can you hear me? Yeah. Well, we use the method which is life cycle assessment, LCA, help us make smart decisions. We didn't want to save money, but cause big environmental problems and costs later. We implemented LCA in 3 key steps. First of all, we define the LCA scope and collected data. We set the scope to cover the project's 40-year design life. We looked at 5 key things. First is material production, like making cable insulation. The second is construction, like fuel used by ships. Third is operation, like power loss during power transmission lines. Fourth is maintenance, like repairing cables. The fifth is end of life, like recycling old cables, especially copper. We collected data from over 10 suppliers. For example, 1 ton of XLPE insulation produces 80 kilograms of carbon. And 1 ton of oil installation produce 120 kilograms of carbon. We also did our own tests, like XLP cable, whereas 0.5% per year, versus oil cable, whereas 2% per year. Second, we analyze environmental and cost impacts. We use LCE software to calculate two things for each opinion. First is environmental impact. Oil insulated cables would leak oil about 3 times in 40 years. Each leak flows 500 square meters of sea. LPE cables have no oil leak risk at all. Second is cost impact. Oil cables are 20% cheaper at first, but they need 10 repairs in 40 years. Total repair cost is 3 times the initial cost. XLPE cables cost more upfront, but only need 2 pairs in 40 years. Total cost is 1.5 times the initial cost. Thirdly, we optimized our plan based on the LCE result. We choose XLPE cables. This decision saves 1.2 million tons of carbon versus oil cables and cut 40-year total cost by 25%. We also use LCA to optimize construction. LCA shows that using helicopters to build towers instead of temporary bridges reduce sea demand by 80%.
I'm sorry, but I will need to interrupt you here for the sake of time. So Maya, is this an answer to your question?
Not honestly, because I was just looking for to see what risk assessment measures they took. But yeah, thank you for your answer. For the sake of time, I will just pass it to the other jury.
Yeah, I see Jose Carlos has a question. That's going to be the last one because otherwise we're running out of time.
Right. Yes. Congratulations on your project. During the planning and design phase, you introduce philosophy, goals, and resources. Regarding the goals, can you explain the difference between work quality and operational quality, please?
Excuse me, I don't understand the question.
Yes, during the planning and design phase, where you explain the whole life cycle multi-objective comprehensive optimization planning and design method, you have a philosophy, goals, and resources. So you have set up 4 goals: engineering quality, development quality, work quality, and operational quality. So can you please explain in your project, in your approach, what is the difference between operational quality and work quality goals?
Oh, sorry,
Thank you for the question. The Guojiao #1 Zhoushan offshore power transmission project includes 2 projects. One is the 500 AC submarine project. Another is Zhoushan terminal base stage VDC project. So as to the DC project, we need to consider more about the whole construction and design. But as for the operation period, we will use some the monitoring, so we can better know the situation of the whole project. This is the operation stage. As for the work, I think we partly combine the work stage and the operation stage, because we have the operation and we also have the maintenance. For example, we need to maintenance once a year, so we can keep the project go steady. And then we need to operation at the station. We need to stay at the station. We don't leave the station. We have 2 operators in the station and 3 shifts for 6 days. So we will combine the operation work and the maintenance work. Thank you.
Right. Okay.
Thank you very much. We need to move on to the next project for the sake of time. Thanks again, and off to the next presentation.
Thank you, Willie. And now we go over to the third project that is coming from Hangzhou Dian Medical Laboratory Center. And the title of the project is Risk Management of Specimen Loss based on Iaq Ea. So please get over to the presentation.
Dear judges and teachers, hello everyone. I'm from Hangzhou Dian Medical Laboratory Center. It's a great honor to be here today to share our practices and achievements in quality management for sustainable development. My presentation will focus on Iaq Ea-based risk management of specimen loss. Let me begin with a brief introduction. Founded in 1996, Dian Diagnostics is a leading third-party medical diagnostic service provider in China. We currently serve over 22,000 medical institutions, process more than 100 million test samples annually, and offer over 4,000 diagnostic services, guided by our corporate mission to ensure equal health access for all citizens. We remain committed to sustainable development through quality management. Next, I will share from the following 10 aspects. First, an introduction to the circle. To begin with our project, we need to go back to January 2024. On that day, we formed a special team called Specimen Guardian Circle. The team consisted of 1 circle leader, 6 circle members, and 2 experienced counselors. Take a look at our Dian logo. Each part carries special significance, symbolizing quality, green healthcare, the global health industry, and medical laboratories. Next comes the critical phase of specimen selection. In our practice of quality management for sustainable development, we fully recognize the importance of specimen and root cause management. The loss of specimens not only compromises medical service quality but may also severely impact patient health. As previously mentioned, Dian conducts over 100 million specimen tests annually. Ensuring zero loss of these specimens is therefore of paramount importance and carries profound significance. Through the application of quality management tools, the weighted scoring method was used to evaluate and score multiple topics, and the topic of sample loss risk management with the highest score was selected as the theme of this activity. Furthermore, through in-depth exploration of the topic's background, we conducted comprehensive analysis from multiple perspectives, including patients, medical professionals, laboratories, and societal needs. By fully considering the demands of healthcare providers, enterprises, market, and society, we reaffirmed the theme as Iaq Ea-based risk management of specimen loss. The scope of the activity was confirmed to span from the initial handover of specimens between front-end hospitals and distribution centers until their final destruction. While hospital laboratories can process patient specimens directly in the testing department, Third-party independent laboratories require 2 separate transportation stages throughout the entire process, including specimen handover, transportation, reception, testing, and storage. Various potential failure modes may occur. We must implement optimized corrective measures to minimize or eliminate specimen loss risks to the greatest extent possible. After finalizing the theme, we developed an activity plan and mapped it into a Gantt chart. Using the 5W1H method, we defined the specific content for each step. Throughout implementation, we adhered to the PDA cycle to ensure systematic and scientific execution. We conducted extensive data collection. We fully utilized available resources to gain a comprehensive understanding of the current situation. The final workflow diagram was developed, dividing the sample flow into 5 main stages: hospital to distribution, distribution to sample room to department, interdepartmental or intradepartmental phase, and post-testing temporary storage in cold storage followed by destruction. Next came the hazard scoring and decision tree analysis phase. Our team conducted brainstorming sessions to thoroughly examine the 5 major processes, ultimately identifying 14 sub-processes and their corresponding 27 failure modes. For example, the 3C process from specimen room to department corresponds to 2 failure modes, specifically 3C, specimen dropped during transport by department staff, 3CB, specimen dropped while staff retrieved specimens from the sorting machine. So what should we do about these 27 modes of failure? Don't worry, the quality tool hazard score and decision tree analysis point the way for us. The first is the hazard score. Based on the document application of risk management in medical laboratories, we established hazard scoring criteria focusing on 2 dimensions: probability of occurrence and severity. The hazard value is calculated as probability of occurrence multiplied by severity, similar to traffic signal color codes. We defined gray as ultra-low risk, orange as low risk, yellow as medium risk, and red as high risk. Additionally, when severity reaches or exceeds 4 points, even if the probability of occurrence is considered unlikely, it will be classified as high risk. With these standards, we conducted a detailed analysis of 27 failure modes. We systematically evaluated other failure modes, ultimately identifying 9 items with medium to high risk levels requiring prioritized attention. Therefore, we carried out the formulation and implementation of failure mode countermeasures. For these 4 failure modes, we analyzed the potential causes and formulated detailed implementation measures. For example, regarding the failure mode of specimen loss during transportation by 3C department staff, we identified 3 potential causes: 1. Unsealed transport boxes, 2. Single-person transportation failing to detect specimen drops promptly, 3. Inefficient transportation routes. Accordingly, we implemented 3 measures: 1. Procuring sealed transport boxes, 2. Implementing dual-person transportation with 1 staff member leading and another following, 3. Establishing fixed transportation routes to minimize specimen loss risks. So how do we monitor and confirm the effect? It is mainly carried out from 3 aspects. The first is process drill. We have carried out office simulation drill and on-site drill, and the risk of specimen loss has been effectively controlled and the countermeasures are effective. The second aspect involves comparing key process improvements. Taking the 3C project as an example, we observed that after optimization, measures such as specimen box sealing, dual-person transportation protocols, and fixed transport routes have effectively reduced specimen loss risks, demonstrating the effectiveness of these countermeasures. The third is the change of hazard score. The hazard value before improvement is greater than or equal to 9. The hazard value after improvement is less than or equal to 3, and the risk is changed from medium high to low, and the countermeasures are effective. In addition, we conducted an evaluation of intangible outcomes, which showed significant improvements in various aspects such as the application of QC tools, innovation capability, communication skills, team spirit, initiative, and self-confidence. With the above countermeasures having achieved phased results in practice, we have also developed 6 standard operating procedures to ensure the sustainability of quality improvement. Finally, we conducted a review and improvement, made a phased summary of the advantages and disadvantages and the direction of future efforts, and confirmed the theme of the next stage as inter-room quality evaluation and risk management through the weighted scoring method. I would like to emphasize that while our Specimen Guardian Circle project has achieved notable results and been implemented nationwide, we must continue to enhance our quality management practices to make greater contributions to achieving sustainable development goals. Thank you for listening. Please provide feedback.
Okay, thank you very much. Do we have someone from the company available for answering questions? We should have. Ravikant, you have a question?
Yes, I do. Thank you for your presentation. Do we have a company representative?
We should have, but see who was reported as contact. Yeah, apparently nobody joined, which is a bit of a pity. I didn't get any mail about problems, so yeah, but I don't see her here. And I thought there was somebody else maybe who would be. Okay, in that case, we can't ask questions. I'm sorry, Ravikant.
No,
but we can move on to the next presentation.
Sure, sounds good.
Yes, thank you, Willie. Now we leave China. We are moving in the western direction here to follow the time zones. Now we have evening in China, so now we move to India, there it's late afternoon, and to Ashok Leyland Limited. And this project is about iron ore extraction from grinding waste. So please start your presentation.
We are from Ashok Leyland Chennai unit. We are proud to present the Iaq Quality Sustainability Award 2025 Global Round. This is our project title, Iron Ore Extraction from Grinding Waste. This makes a significant contribution to the carbon footprint reduction, circular economy, and aligns with SDG goals 9, 12, and 13. The overall generation of grinding waste in India found to be average of 50 lakh metric ton of grinding waste. At Ashok Leyland, we take immense pride in our legacy that spans over 75 years since our founding in 1948. Our vision is to be a top 10 global CV player. We are headquartered in Chennai, Tamil Nadu. Our facilities are strategically located in Tamil Nadu, Maharashtra, Rajasthan, and Uttarakhand. Globally, our presence spans 49 countries, reflecting our focus on strategic international expansion. We have manufacturing, assembly facilities, including e-treatment at Ennur facility, Ashok Leyland. Let me define the business context. These are the three pillars of sustainability: healthy environment, healthy economy, healthy society. AL focuses on carbon footprint reduction, energy conservation, and our team focuses on hazardous waste reduction. As a team, we are committed to minimizing hazardous waste at our Ennur facility. We adapted a prioritized approach to waste management, identifying and addressing the most critical waste streams first. Last year, we successfully completed the paint sludge recycling project. This year, we have taken up grinding sludge as our next priority, launching an innovative recovery project to further reduce hazardous waste and promote sustainability. The grinding sludge disposed is in 5.2 category of hazardous waste. We have an authorized recycler by name Jepil at Ranipet, 160 km away from our factory. They are engaged in co-processing of hazardous waste and they supply this processed hazardous waste as an alternate fuel to the Dalmia cement factory, which is 300 km away from our factory. The annual disposal quantity of grinding waste is 120 metric ton and disposal cost is rupees 10.9 per kg. We focused on gear shop, the grinding waste generated in forged steel components machining process. We have 23 machines which uses coker cool water base to generate water based grinding sludge, and 11 machines which use neat oil macron to generate oil based grinding sludge. The grinding waste consists of workpiece part EN353 etc., grinding wheel which is silicon based, and coolant with chemical. We also identified the presence of hazardous substance classified under R65 and R66 in the grinding waste, indicating that the material poses potential health and environmental risks. To better understand the composition of the grinding waste, we submitted samples, both water-based grinding sludge and oil-based grinding sludge, to the National Testing House Laboratory. The analysis revealed a significant presence of ferric oxide Fe2O3 in the sludge. The grinding waste primarily contains silicon, nickel, Fe2O3, chromium, and Al2O3. Laboratory analysis revealed that ferric oxide constitutes about 59% of the waste, representing a significant source of iron. Based on this finding, we decided to extract iron from the grinding waste. Our team used the TRIS methodology to identify breakthrough opportunities that could unlock the potential for resource recovery from grinding waste. We have identified the breakthrough factor as transforming the defect into resource, and also we identified the homogeneity principle, which is the material compatibility in interactions. We used periodic table to identify the properties of 5 elements: silicon dioxide, nickel, Fe2O3, chromium, and Al2. We adapted the 3I approach: imitate, improve, and innovate. As a part of this, we revisited the composition of grinding waste to reduce impurities by studying the presence of nickel, chromium, and aluminum. We analyzed all 5 elements in the grinding waste to determine feasibility of thermal process, and the same is studied and tabulated. Out of this, Fe2O3, which constitutes 59% of the grinding waste. Aluminum can be separated using a thermal process, while silicon, nickel, and chromium require a chemical process for effective separation. Our team decided to separate unneeded silicon dioxide, aluminum, chromium, nickel, which constitutes 3%, and extract iron Fe2O3, which is 97%, through mechanical and thermal process. So as a part of solution development, we approached the magnetic separation method. Since magnetic separation was not giving desired results, as slag and iron was attracted and found to be time consuming, it was dropped. So we gone for an alternative solution, pyrometallurgical process, as a viable solution. After evaluating alternatives, we finalized the pyrometallurgical approach and implemented the following steps in our project. As a first step, collection of grinding sludge. Next, dewatering, demoisturizing, decarbonizing, deoxidation, sintering, slag separation, and finally the iron extraction. So in this innovation model of POC at stage 1, we have collected the grinding sludge and categorized it into oil-based grinding sludge and coolant-based grinding sludge, as shown in the slide. In stage 2, in the dewatering, we have gone for the dewatering of the grinding waste, as thermal drying is an effective sludge treatment method for dealing with the large volumes of sludge. In stage 2, for oil removal from the oil-based grinding sludge, we used magnesium chloride and alum in the ratio of 1:1000. And alum slurry with the hazardous waste, we could see the success rate. Oil was cracked and removed from the hazardous waste grinding. Further, you can see the separation of water-based grinding sludge and oil-based grinding sludge. You can see the oil removal process of waste-water chemical ratio of 1:1:0.1, as shown in this. In stage 3 POC concept, we can see the demoisturizing. The grinding sludge spread in the big trolley for demoisturization. In POC stage 4, the decarbonizing process refers to the removal or reduction of carbon content from metals, typically during refining or recycling operations. You can see the proof of concept here. And at stage 5, deoxidation done, which refers to the removal of excess oxygen from molten metal. This is achieved by adding substances with high affinity for oxygen, which forms oxides that are either gaseous or easily converted into slag. In stage 6 POC concept, sintering done. Sintering is a thermal process where fine particles of metal or ore are heated to a temperature below their melting point until they bond together. Stage 7, melting involves the heating the material to a temperature above its melting point, converting it into a liquid state. The process concludes with slag separation followed by iron recovery, which is then converted into steel shot, coins, and bars as the final product. We made a trial one. We took 500 gram of iron ore, placed it in a graphite crucible and attempted remelting in the furnace. The material required extended heating time but did not achieve a fully liquid state. A significant amount of slag was formed and only a small quantity of metal was extracted. Based on our observation, the oxidized nature of the material prevented it from melting directly in the induction furnace. We decided to add the steel shots in stage 8 POC concept. and made a trial 2 observations. Out of 900 gram of material, 874 gram was recovered, with the remainder lost as slag and fumes. When 850 gram of steel shards were melted together with 50 gram of iron ore in the crucible, the 50 gram of iron ore yielded approximately 20 to 25 gram of metal. This indicates a metal recovery rate of about 40 to 50% from the iron ore. In stage 3 trial, we made an observation. 5% catalyst steel was utilized to optimize the process for large scale iron. Achieved 80% iron recovery efficiency, while 20% of the material was converted into slag. You can see the big iron bar as shown in the slide. This innovative project of iron from grinding waste was reviewed by Central Pollution Control Board, and they have given the approval. You can see the expert committee giving the approval, and we also further discussed in the Tamil Nadu Pollution Control. Our team first time in India converted 100% this grinding waste, which is hazardous category, into a non-hazardous category. We have achieved the 52% recovery of iron in trial 1, 70% recovery of iron in trial 2, 80% recovery of iron in the large scale implementation in trial 3, and remaining 20% is the slag. Really, this is the breakthrough results. You can see the entire hazardous category converted into non-hazardous category, 80% of the iron which is non-hazardous and 20% of the slag which is non-hazardous. This is the breakthrough result. Let me brief on the savings and sustainability summary. Total generation is 120 tons per year of grinding waste. The current disposal cost is 10.9 per kg. The annual disposal expense is around rupees 13 lakhs. If you look at the iron recovery rates, initially we got 52% at foundry end node. Later in the vendor 1 and vendor 2, we had a 70% and 80%. So the expected recovery was 96 tons per year, that is around 80%. Revenue potential, when you take the iron scrap reference value of 32 rupees per kg, our annual savings stands out to 30 lakhs. Look at the environmental benefits. We have eliminated hazardous waste incineration, avoided 160 km transportation to authorized recycler, reduced diesel usage and carbon emissions, and circular economy enabled. This is the summary of benefits. The total disposal cost eliminated, incineration not recurred, reduced the carbon footprint, we promoted circular economy. We are proud that we have done this project in our mother plant, Ennur. In the context of business environment, as a part of horizontal deployment, we also found the hazardous waste like grinding waste is being disposed across all AL units. That was tabulated here. The disposal cost spent for 178 metric ton on an average was 19.58 lakhs. If you take out the conversion cost of rupees 8 per kg, on an average for 125 tons per year across AL, there is a savings of 40 lakhs per year. Let us look at the carbon footprint reduction. On an average, you can see 25 to 52 tons of CO2 emitted for the mining and extraction of 125 tons of iron was completely eliminated. When you have the iron extraction through coal mining, you can see the lot of energy consumed as shown here. This innovative project was shared to the National Productivity Council, Center for Environment Studies, Anna University, IIT Madras and Delhi. As a part of knowledge sharing session, this innovative project was presented to various colleges and student communities across Tamil Nadu, inspiring them to embrace sustainability and the principles of circular economy. Thank you for the opportunity given for presenting this innovative project. Thank you one and all.
Okay, thank you very much. And I see 2 people are available to answer questions. Anyone with a question? I see Ravikant first. Go ahead, Ravikant.
Thank you, team, for that presentation. It's very impressive work. A couple of questions. The first one is that whilst you have reduced the carbon footprint through recycling of iron, you have also added catalysts and pellets. So how does that impact the CO2 content, and to what degree have you actually reduced it?
You're still on mute.
Thank you, sir.
Okay.
Thank you, sir. Thanks for your question. Thanks for this great opportunity. Sir, actually, this iron grinding waste, hazardous waste, going for the incineration, there itself we are having carbon footprint. Whereas while doing this iron ore extraction through pyrolysis process, it's a proven concept where we are not doing any carbon footprint compared to the incineration. So earlier, before status is more than current after improvements.
No, you didn't answer my specific question. You are adding materials in order to regenerate. So what is the negative impact of those materials?
Sir, we are adding yes, we are adding pellets that are generated from the iron ore itself. Actually, the same material will be added. It's for startup.
Okay.
Steel balls, which are created from the steel itself, catalyst. That's all.
Okay. This pyrometallurgical approach is a well-known approach, right?
Yes.
So
yes, sir.
how do you say that this is an innovation in that case?
Pyrometallurgical approach is well known for the waste material melting, all these things. But in this process, grinding waste with oil is comes under the hazardous category. We are doing oil cracking. We are removing the oil and demoisturizing, dewater. So this is the concept where the two technologies integrated along with pyrometallurgy to extract the iron ore from the hazardous category waste.
Okay. If that's okay, quick question. You have shown, you have referred to TRIZ, but you didn't develop on any of the solutions coming out of TRIZ. So I'm a bit puzzled.
Thank you, sir. Sir, actually, we had a great training from Ashok Leyland Learning Center and Development TRIZ tools for one-day session. So that is, we know that TRIZ is used for the innovation tool, where we are using last 3 projects. We found that porous
I
understand.
Material. I understand. My question is simple. You mentioned TRIZ, but you did not use any of the approaches coming out of TRIZ. You just left it there and followed your pyrolysis process. So where did you actually use TRIZ in this project?
From the initial stage, how to identify the content of the grinding waste. From lab report, we found that silicon is there, aluminum oxide, chromium oxide, nickel oxide, like that is there. So during that time, we gone for the TRIZ. What are all the principles? What are all the features available which is relevant to our matrix? Like that, we used, sir.
Okay,
Ravikant, I will give the word to Carlos for a last question.
Thank you. Congratulations. Congratulations on your project.
Thank you.
When you explain about the background, you indicate that the treated waste, then it's given to third parties. And that waste is treated again and then used in the cement industries. Can you elaborate more how the treated waste again is used in the cement industries? How this is linked to sustainability?
Sir, actually earlier the hazardous waste gone for the incineration for cement industries, where they are producing carbon footprint and cement production is there. But every time we are procuring raw material, iron ore for the foundry operations, manufacturing, casting material. Now we are diverting, circulating this waste into wealth, like iron ore generated from the manufacturing, machine shop to foundry process requirement raw material, circular economy is achieved like this, sir. Instead of in linear motion, we are circulating in our factory foundry process raw material utilization from the waste, from the machine shop waste.
Okay, thank you very much. For the sake of time, we'll interrupt here because next up is a break. And the break will be 10 minutes instead of 15 to make up for the time. So thanks again. Thanks to all 4 teams for their presentation, and see you all in 10 minutes at 12:25 when we will start with the next presentations. Thank you.